Hello, everyone. I'm really excited to be here with you today at Devoxx. My name is Nikos Kousiadis. I'm the AI lead at Netcompany Enterprise Solutions. And together with my colleague Mike, we'll be sharing some of our insights and learnings from our experiences around RAG. Now, RAG systems have been a hot topic lately in applied AI. So we want to share with you today how to move beyond the basics and how to make these systems actually work in real-life scenarios. So a quick word about us. Both Mike and I work at the Data Intelligence and AI Technology team at Netcompany. We work on AI solutions across different industries, finance, economy, energy, and public sector. And a big part of our work recently has focused on RAG systems and AI agents. We have faced the usual challenges, like noisy data, evolving knowledge, or evaluation headaches. So today we're going to walk you through and how we overcome all these obstacles. So here's our plan. We will start with what is the Retrieval-Augmented Generation system, so to be sure that we are all on the same page. Then we'll talk about real-world challenges that we face. And finally, we'll present our advanced approach we've developed, which involves multi-agent orchestration, multi-source knowledge bases. So, starting from the top, what are the systems? The RAG systems mainly are consisted of two main components, the retriever and the generator. The retriever is responsible to pull all the relevant data to a user query, and the generator is responsible, using an LLM, to craft a good answer. So, why do we use them? Because static training of LLMs isn't feasible in real-life scenarios. It's too slow, too expensive, and you lose the ability to inject real-time proprietary knowledge. So RAG systems gives us flexibility, gives us control. Sorry. So, and when do we use them? There are many use cases in different areas, from internal knowledge assistance on company wikis, legal documents, etc., to customer support services with chatbots. We can use them for data-driven insights in many areas like healthcare, finance, and law. And of course, it's an accelerator for code development and creation of documentation for our code bases. So here's the typical setup of a generic RAG system that you will find out there. The RAG system takes a user query to the smart retriever. The retriever is responsible to pull the most relevant data from a knowledge base. How do a knowledge base is crafted? In general, it uses input data, mostly documents. It preprocesses them. Then it creates the chunks. It calculates the embeddings to get the semantic meaning from them. And all these are uploaded into a knowledge base. So the retriever gets the data, tries to find the most relevant information with many techniques, keyword search, semantics, hybrid methods, and sends them to the augmentation layer, where we combine the user query, the knowledge that we have extracted, along with any prompts and instructions that we have created. And using the LLM, we can respond to the user. So in the real world, data comes in many sizes and in all shapes. So we have many cases, legal documents with appendices and footnotes. We have tabular data, where the structure of the data have a special meaning for the knowledge base. We may have scanned documents like lab reports. We may have flowchart with where the visual logic has a meaning, and we have embedded texts. Also, we may have handwritten reports, and we can also have mostly combination of all this along with images. So a basic retriever is very difficult and faces many challenges to retrieve the most relevant info from relevant to the user query. So how do we, what do we do for all this? We introduce the AI agents. Instead, of trying to build a monolithic systems, a system that tries to combine all this info and give the answer, we break it down to different AI agents, where each AI agent has a specific task and specific components. So what it is an AI agent in general? At its core, it has an LLM. We have the prompts and instructions that we give to the agent, a specific configuration to optimize its outcome. We may give it a knowledge base, one or more knowledge base, and some tools like external APIs, web search, and other endpoints that will help it make some action. So what in general it does, it retrieves info, it validates data, it makes actions, it automates procedures, and as we all know, it's very capable of generating content. So I'll hand it now to Mike to have a deep dive into our agentic framework.
Okay, hello from my side also. Now we will go through our approach, our architecture. Mainly our architecture combined from, let's say, three components: the agents, the structured knowledge base, and of course the procedures that generate this structured knowledge base. Okay. First of all, we have the agents. Okay. We have identified some key structures in our architecture. Okay. We have a first component that is an orchestrator. An orchestrator communicates with the user, makes some more specific queries, asks the user for additional information at some point of the whole process. We have identified the component, we name it researcher, that communicates with the whole knowledge base, decide which part of the knowledge base will retrieve data, reasons which content from the knowledge base will read, and gets this content. Okay. Also, in most of the cases, this is the space that we generate the response. Okay. And the response after that, we pass it through a third component we have identified it, which is the validator. Okay, the validator is a very crucial component in this setup because it validates that we don't have any hallucinations, we have answered the query. Very important, it removes content that is not useful, and then pass the answer to the user through the orchestrator. All these components communicate together, and the goal is to provide what answer the user needs. Okay. The second major pillar, let's say, is our knowledge base and how we construct it. Okay. As Nick said, we have a lot of different sources. We have document, images, procedures, whatever. Then, first of all, we have to normalize all the different databases, because from each source we may generate a different database and different knowledge base. Okay. We have established that this knowledge base needs to be at some degree standardized. Have the same columns, have the same content. So a big, let's say, thinking in how we design this system is how we normalize it. Okay. We have specific procedures that generate the knowledge base for each document. In this procedure, we may use the LLMs, we may use entity identification, we may use OCR. We have a different approach how we can handle the tabular data. Okay. The SQL databases, the tabular data we may find in Excel files, and so on. We do it using examples in the prompt, using specific prompt engineering. And after that, we need all these different databases at some point to investigate if they can be connected, okay, to retrieve further information between the two databases from their connections. Okay, we can go to the next. The next pillar of our development is the evaluation framework. The evaluation framework is one of the most important things because this is the main tool, along with the experience that we gather from our development, of how we can proceed with the development. Okay. Should we use validators? Is the validator not necessary? Will we need to make some changes in the knowledge base? The tool that we decide to make this decision is the evaluation framework. How we do this, what we compare with, okay, we compare with user cases that the users have provided to us through the business procedure. Also, we have established flows that generate our cases, our answers and questions. Okay. How we do this evaluation? We have metrics, text metrics. How similar is the response with the answer, the suitable answer? We have a rule base. Okay. About the size of the response of the other component of the report that contains specific things that we need to pass to the user or no. Of course, we have multi-label metrics. Do we have the chunks, the things, all the necessary things that is needed to generate the correct answer? And of course, we have a agentic approach. We ask the LLM to validate the procedure. And of course, we incorporate the user feedback. So we have established, let's say, front-end tools that the user can provide if he's satisfied with the query we give him, we give her. What we're looking at the response. Do we have the correct response? We're looking at the retrieved content. Do we have all the retrieved content? Okay. Which steps the flow go through, which ports the flow go through. And of course, we can validate with some business cases, but business logic that we have, that the user provide to us. Okay. So this is the main ingredients that we have identified. The main thing in this procedure, in this development, is to identify which is the best and create our solution. So, to have a quick wrap-up, what we have seen, we have discussed about what is a general approach, a generic approach of a RAG system. We have seen some example of the challenges that we face in the real life. And we have presented to you how we can tackle this and what tools we use. The main thing we use is the agentic approach with the agent that we have identified it. Is the multi-source knowledge base. And of course, the validation framework.
That's all. Thank you.
I think we have time for some questions.
Yes, I think we have time for some questions. So, yes, please.
Your validator agent, the last step was check for hallucinations. But
Yes.
how do you do that?
Based on the knowledge base. We have the knowledge base, we have the actual knowledge, where the hallucinations are based with new instructions, different prompt engineering, and also knowledge that we can retrieve.
How does the whole thing know it's hallucinating? I mean, then it cannot not hallucinate in the first place, right?
Yes, but go.
In some cases, the hallucination can be checked if in some selected, let's say, suspicious response, you can use a more experienced agent and more experienced model. So in some cases, you use, let's say, a level 1 model. And if you have some suspicious case, then you pass it through a more experienced, a more complex model. This is one approach that have checked that it works in one solution, that we had a lot of hallucinations. Yes, please. Yes. No, the more mature model, the main task for this sub-agent, let's say, is to take the information that we give the smaller model and to provide an answer of that.
Along with the retrieved content.
Yes,
right?
along with the
retrieved
yes,
content.
yes,
So
yes.
we don't go again to the database.
Yes,
yes,
yes, yes.
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 Of course.
Mm-hmm.
Did you check them? Do you have human checking these cases, or you trust the AI that has generated valid cases?
We make sample checks to these cases. If okay, first we generate, let's say, a data set. Okay, it's a process that it has iterations. If we are okay with that to validate our solution, and it's like 100 cases, we may look at it one by one. Okay. If we want further 1,000 response to validate our solution, then we sampled it, and a person checked it, not 10% of this, something like that. It's not a bulletproof procedure end to end. But we may to take all the necessary steps to have a big validated result to the user. Mm-hmm. Yes, please.
Yes.
Do you referring to some specific step? The first step, yes. Mm-hmm. The purpose of the retrieval, if I understand correct the question, is to provide the LLM the additional information which is not trained on. So we somehow there's one specific a very big field how you approach this, the retrieval, but the main thing is that the LLM does not know the customer-specific information, so we get this and we append it to the query and provide the LLM with the additional content. Okay, of course.
Yes, please.
So all of your agents on the agentic framework, are the LLMs both doing in-context learning and fine-tuning? Like, is this a hybrid approach, or every agent of yours is just taking some examples and then generates out?
Please.
At this point, we haven't tried the retraining because mainly we are not sure about at least we haven't tried the retraining in the production solution, okay? Because all the POC, let's say, that we have run, we are not sure about the end result regarding the retraining. So all the agentic approach, all the agents are LLM calls, okay, with tools, with additional content. So, and let's say each one of this, the validator, the researcher, or the orchestrator, inside there may be another, let's say, two-step agentic approach. So these main areas is, let's say, an abstraction of the code that we use. Inside the orchestrator, we may have two different agents. One has tools, one does something else. But in order to present the architecture, we made these abstractions. But the answer is that inside there are mainly LLM calls because the retraining is not something that we step on, at least for the production level. Yes, of course.
Are you utilizing the LangGraph framework?
Yes.
Yes.
Yes. Yes, please.
How did you target the latency making all these calls to the LLM?
Yes, this is one big thing. There's another, the additional framework that is performance framework. We evaluate based on the needs of each case. We evaluate how many calls are necessary in order to achieve the latency that we need to achieve. So this is another variable in our development. We didn't present here, but it's a solid question. We need to include the agents that it's okay not to make our solution slow.
Without losing quality,
Yes, of course.
at the same time.
It's a trade-off. Quality, performance, all of
Cost,
this.
All of this.
Because I was thinking,
Mhm.
Retrieval makes a call to the LLM, and then the retriever, of course, will make a call to the LLM. Then the validator will also make a call to the LLM.
Yes.
So you may have 3 or 4 or 5 calls
Sometimes it is not necessary.
in order to get a response.
Yes, if it's a very easy, use case, we may have only one agent. But in general, we need more. But yes, of course, we need to balance it based on this.
It all comes to the accuracy, let's say, that the solution needs. If we need to find one specific information through thousands and thousands of documents, we may need to have a validation, we may need to have a bigger latency. But in a lot of cases, as Nick said, it's not necessary to have all of these LLM calls. And also, in some cases, we can ask some specific question to a smaller, even smaller model. So it will be even faster. Yes. No, it's a decision from our side when we decide it. If we include an orchestrator, if we include a validator, in which model we run all of this task and so on. And of course, yes, of course, there's in some cases, the one LLM decides to go through the validation procedure or not. This is also true.
Sorry, we have no more time, but you can come and discuss anything you need offline. Okay.
Yes.
Thank you all.
Thank you very much.
Thank you very much.